Hello, everyone. My name is Soma, and today I'm going to present on the topic for the term project, and that's related to precision farming in India and how the new technologies such as big data analytics and so on is going to actually improve or is going to be helpful in terms of improving the farming situation in India. So on the agenda, what we have is we'll briefly talk about the introduction, and we'll also talk about what the problem statement is and why we want to do this new technology rise in terms of farming and all that. Then we look at what's the path forward. So after the problem, we'll discuss on how actually we want to project this and see what best options are available. Of course, this is in conceptual paper, so of course, and there is a lot of information and data available on the internet. However, I put together a lot of thought process to bring this together. And beyond that, we'll also look at how the Internet of Things, or basically Internet of Agriculture things, and that's another interesting topic that we'll go through. And the new technology, which is the big data, and we'll go through what is big data about and what are the various opportunities and challenges associated towards big data, and what are the ground realities basically in India in terms of how exactly what are the implementation related challenges and issues that you come across. Then we will end the session with a conclusion or the summary of the findings and the approaches and advantages and things like that. Okay. Now, going into the introduction, right? Basically, saying India is an agriculture-centric economy, and which contributes to about 18% of the total GDP, and it is also the largest employer with about 49% of the total workforce. Right, so most of the people, or half of the country, that relies on agriculture. That's what it means, right? Or I mean, if not the country, but at least the working class, including the people who are on the jobs, IT, or wherever, regardless of those. But farming is one of the key areas. And also, basically, the interest is that the government aims to grow the sector at least like 4% annually, and that can be determined by using new technologies, globalization, and also finding out various markets where to explore, right? And it's not only about production, but you also have to make sure at which locations and what you're going to sell at the right time in the right place. So it's all about markets as well. So by using the Internet of Things, such as big data and data analytics and all that, which is useful to capture the information, right, and generated from there's a lot of data that's being generated. So that is between the pre-harvest to the post-harvesting cycles, which is the full end-to-end. In reality, you're talking about the whole end-to-end process. And there's a lot of information that is generated, and there's an intent that you want to actually capture that or capitalize using that information in terms of providing the uh, timely caution or precaution or advice to the farmers in terms of what is the water content in the soil, what is the strength of the soil, or in terms of the pesticides usage and those kind of things, and also even the weather for that matter. So you even want to give precautionary advices towards the weather and things like that. And so the whole idea is basically how you want to improve the agriculture farming using these new technologies, right? And the intent is to actually enable the farmers to get the minimum selling price or the minimum support price, otherwise called as. So that's for the yield which they produced, right? And then again, by giving better inputs and governance in real time for sowing, harvesting, and production, So these are the various areas in which the farming that happens, or the cycle of the farming happens, right? So the use of this precision farming technology not only increases the productivity but also integrates the whole supply chain for the farmer. So we are saying it's just not the production, but the whole process of the inventory, the storage, or even if you have to use the cold storage for that matter, or the vendors who are going to buy the output or the product from you, right? And whatever the yield that you have generated. So all of these, right, the integration of the entire supply chain to from the end to end. So it's just not about increasing the yield by a 25% or reducing the what you call the expenses or the cost incurred by a 30%. That's not the only intent, but you want to take it forward, right? So some of the traditional farming methods, right, such as the crop rotation and or even subsistence farming, right? Now, crop rotation potentially is labor intensive, and it requires huge land, which is the estate, otherwise called as, and high water availability. So these are some of wherein in the crop rotation, you, over a period of time, like sorry, for a period, like if you invest or sorry, if you try to farm something or a particular crop, and after 3 or 6 months, right, you want to rotate and to strengthen the fertility of the soil, so you actually go to another place and try to continue the farming into a different location, but not on the same site which you have prior done. And so you are rotating the crops in between here and there, right? And subsistence farming is another method where you produce some of these like wheat and rice and other things. And potentially back in the olden days, you just produce that or the volume or the quantity of production is just enough only for that particular local community, right? And it's not basically, which means you're not making profits out of it, right? So, and also the affordability, right? I mean, in terms of like the if you want to get into an high yield produce, then that definitely requires a high capital investment, right? And also there's a lot of dependency in terms of monsoon. Monsoon is otherwise called as rainfall, and there is not just enough water to fill those water bodies. And potentially most of Indian water bodies are dependent on the rainfall, and if there's no rains in a particular year or in the season, and so your the whole farm output is going to reduce, and the economy is going to go down, right? And also some of these are the lack of irrigation facilities, and also the government policies to protect the welfare of the farmers, which doesn't support the minimum support price or the selling price, crop failures, and even farmers' suicidal deaths are also one of the major causes of distress um, for in India currently, and this is where the issue is about. So, with that problem statement, we look at what's the path forward, right, and how we want to really handle these kind of situations. So, if we if you discover, invest, and actually, yeah, invest into new technologies such as the Internet of Agriculture things. Again, either you call as IoT or IOAGT, agriculture things, and also into big data, right? And if you can actually find real-time solutions using these technologies. Of course, there are a lot of research going on in these areas, and some of these are really the big data and technologies like this, if it's really helpful to the people or to the poorest of the people, that is when you see the real value add. of these technologies, right? So that is one of the areas, and so there's a lot of research and discoveries as still has to happen and continue to happen. And also, again, we are in the 21st century, and we are already looking at using some of these artificial intelligence or the best of the new technologies, and how we integrate them and bring it to the agriculture farming level and those kind of options. And also, we need to integrate a lot of farming systems. I mean, there's not many farming technology based applications and systems, but again, if there are few, and that needs to be all integrated together. So that is another path around. And also, the next option that you're looking at is on the education side. So education, or at least a minimum education to the farmers, to an extent where they can understand how things are, to create a general awareness sort of thing, and not necessarily education per se, but it can also be called as a training sort of thing. And other than that, how you actually create a larger pool of people in future, right? I mean, futuristically, there are some agriculture based universities who are totally focused only on agriculture, but does these universities as of today, are they extending it towards applying some of these latest technologies? The answer is no. So that is another area of improvement that needs to be looked at, but definitely these are some of the options. And the remaining things, such as the policies, the governance, and the regulations and things like that, of course, human dimensions. But most importantly, on the last one, if you look at here, the code and framework, which is the Global Open Data for Agriculture and Nutrition. Now, this is a general body that is being formed by the G8, the G8 summit in 2013. So the entire world wants to come together, and basically any organization, any firm which has agriculture data, they can actually share that information. Excuse me. Yeah, so they can continue to share that information, and also, which is basically it promotes the collaboration to harness the growing volume of data generated by these new technologies to solve the long-standing problems, right? And also to benefit the farmers and the health of the consumers as well. So that is the whole intent where this Gordon has been formed, and primarily it is currently it's an initiative and collaboration between the US and UK governments. So the Internet of Things, now on the left hand side, if you see this is a nice and tiny picture on the indicating how the 21st century farming would go to. And if you have noticed, there are these wireless signal bars on each one of these things, right? And this is what you really want to actually capture. And this is, you could say, the future state. That's why it's the 21st century. I mean, just above a tractor here, you see there is a wireless signal. That means even a tractor, moving tractor, is also transmitting information. And if you see the fields here, the fields also has a signal transmitter that is basically to indicate that you continuously get wireless based information into the system, and that is what you actually want to capitalize, right? And how we do that is in terms of putting sensors on farm production, right? And that basically helps you to monitor the soil health, the water, and the nutrition, the pest control, the energy, the ripeness of the product, or the crop that you produce, or the fruits that you produced, right? And not only that, you also want to create a traceability and tracking mechanism, the whole supply chain management itself, or the whole process itself, right? And the inventory and smart services, those kind of things. So you could actually use some of these latest technologies to put that together and collaborate and bring that information all together. Now, and when you bring that kind of volume and information, right? And you need to have a huge database, right? And database is, I mean, we are not talking in terms of RDBMS or those kind of things. We are talking big data here, right? And within the big data, the five V's of the big data, the most five V's, right, or the most important ones, are talking in terms of volume, which is in zettabytes of data generated through a lot of these transactions, tables or whatnot, and also the velocity, the quantities of data that's generated, right? You need to store that, transmit, and process them rapidly. The speed at which you do that, whether you do it in batches or in real time or in various processes, or you want to do it in streams of data or packets of data, what you call as, right? And even the variety of information, like currently with all the the social media and all that, and basically you can capture the information including the audio video files or data from the PDF files or any of the the various formats of information. And the veracity, basically, you're talking about how trustworthy is this information, how authentic it is, and where is it originating from, and do they have the accountability of this information, and what about the reputation of these data providers and sources? Are they just hacking, or are they just leaking information from somewhere else? Or that sort of trustworthiness also needs to be built, right? And those are all embedded into the big data architecture and the value. So storing is one thing. I mean, if you see the funnel here, and the funnel on the top is so big with various data sources like HTML and serial and whatnot, or the click streams and all of these emails and info. But the funnel, as it goes down, it gets filtered and filtered and filtered, and to a point where you get an actionable intelligence, right? And that's what the value we are talking about. In terms of what statistical mechanisms that you use, and what events do you capture, or the correlations, or the the various hypotheses that you apply, all the analytics. So in the title we have seen, we mentioned about as big data analytics, and it's not big data analysis. So the key difference is that you need to apply a lot of data analytics and big data together. Put together is what you get a real output, and that's what you want to store in the database. So now, with the big data, right, there are definitely few opportunities. Like basically, it's an open data and it's very powerful. And we have it's also an evidence-based tool for long-term sustainable development. Also, to improve the economic opportunities for farmers and the health of the consumers. Right, and potentially this is one of the options, or one of the key advantages of using the Godan. Again, we'll go back to that, but Godan, one of the key motives is to actually create the economic opportunities, and as well as to take care on the health of the consumers. Right, and this information is an open access towards research and meta-analysis and open publication of data. And these are some of the vital resources for nutrition security. And if you look at the picture on the left-hand side, you see that this is the big data, which is within the two key attributes of it is the open data and the open government. All put together is what the Golden framework is. Now, so challenges, of course, everything has a challenge in terms of implementation, in terms of cost, in terms of bandwidth, quality, the connectivity, cybersecurity, the storage, and the ownership, and the decision support tools, and so on, right? So we need to actually organize and integrate the data collected from various sources, and also make it available and retrieve on time. That's another key thing, which is one of the challenges in terms of curation. Disambiguation is about electronic data processing, and that actually converts into an information or knowledge, like a PDF file information. How really is it? You are able to actually get an value or knowledge out of that information, right? So these are all some of these challenges that you have in terms of big data implementation. Now, the ground realities. So again, taking this back into where we are, I mean, if you really want to implement these kind of technology into the farming in India, of course, into the rural, take it to the rural community and all that, where that's where most of in the villages, and not even in towns, but in villages, that's where the cultivation and all that happens, right? So if you really want to take it, now there are few other questions wherein data, basically, I mean, in terms of how much of hectares is being cultivated, what kind of crops are being cultivated, and who is producing what. All of this information, there is basically that sort of availability and data availability, and even the reliability of that information is not available at this point, right? And of course, there will be questions associated to ownership of data and privacy issues. That also is something, one of the real challenges that you pose. Not only that, but even most of these policies, the government policies or the local and the central policies that they try to impart, those are pretty much hijacked, and they are mainly politicized to get actually it's basically done in favor of when you want the people to vote in favor of you, the general public and the farmers and all that, they get elevated only at the time of elections, and after the elections for 5 years nobody wants to go back and really improve or implement those promises, right? And those are some of those policy hijacks. And of course, the intellectual property rights, that is an again area where we really need to plug in some of those holes. And also the scale and potential of the users, right? I mean, this kind of technology, if you really go and give it to somebody who who only owns half an acre, that's really not going to help, because the kind of investment that you got to do as an organization, that you want to go and market and say, hey, I want to give you the service, and by giving the service, this is how you are going to get an improvement in terms of your yield, and cost reduction in terms of the expenses that you're going to incur. But such an high investment on a low quantum of estate or property, I think that's not going to help. So basically, you need to have some hectares and hectares of lands together. Only then probably you could really get the value and real output for that investment, right? So to conclude, basically, we are saying the technology mix in terms of the big data and the Internet of Things together can really help the farmers or benefit the farmers through precision farming by utilizing the crop inputs efficiently. Again, this is all done based on the sensors and all that, the IoT, the bots. And the exactness of the agribusiness can be addressed both. It can actually address both monetary and natural issues that encompass creation of farming today. And the spread of the sensors, it basically frees the farmers from the constraints of uncertain weather, and that's another area where they can in real time they can get the weather information, so they can protect their crops and the produce. So the utilization and selection of the big data, that's the most advantageous, right? And permits efficiencies regarding cost, profitability, and advancement. And it basically gives the farmers to the capacity to utilize the crop inputs more successfully, including the manures, pesticides, culturing and watering system and all that. And I would say, the future research is all about to get through the obstacles and use big data analytics in agriculture for unveiling the proficiency from the raw unstructured data. And that is how you can really see a value out of the technology taken to the common man. Okay, so here I end the session, and thank you all for listening and being patient on this session. So if you have any questions, please email to me at Kadikatla at broncos.uncfsu.edu. Thank you.